Okay, now we're going to look at the disaccharides, or some examples of them. Disaccharides are composed of two monosaccharides, and they're linked together by forming an acetal that we've already looked at. So remember, we had the hemiacetal where we folded or looped a carbohydrate sugar around, and the carbon 5 reacted with the carbonyl carbon, or a carbonyl carbon. And so now we have the hydroxyl group, and we have an alcohol, and when those react, we get that acetal. Okay, so we've added the methyl group, and we have this linkage now, plus water as a result of that. So we're going to lose two hydrogens and a form a water molecule. So when the reaction occurs between two monosaccharides, the bond that forms is called a glycosidic linkage. And that linkage is between carbon 1 and carbon 4 on the second monosaccharide. So we get this 1,4 linkage. So now we have two monosaccharides linked together by that glycosidic linkage, and we again lose a molecule of water. So depending upon the position of the hydroxyl group in the first monosaccharide, so this is this one, the linkage is going to be either alpha or beta. And if the bond is alpha, this linkage is reflected by that oxygen being in the down position. Okay, so the glycosidic bond is down. So this is called a 1,4 alpha glycosidic linkage. If we have a beta, you might see this depicted differently, and I will show you what I mean by that. Another example. So if the hydroxyl group was in the beta position, then the glycosidic bond points up, but it is still a 1,4 beta in this case linkage. The other way you might see that drawn, and I'm just going to do a generic, something like that, not quite as, thick, is like this. Okay. So you may see the beta glycosidic linkage represented this way. So we can hydrolyze that glycosidic bond to form the original two monosaccharides. And in this example, we have a molecule of maltose. And maltose consists of two glucose monosaccharide units linked together by that glycosidic bond. And in this case, it is an alpha. You see it's in the down position. So we can hydrolyze this bond and with a molecule of water, and the resulting molecule is the alpha glucose, and the hydrogen gets attached here. Or I'm sorry, I think I said that wrong, but hopefully you get the gist. So lactose is the disaccharide in milk. We've seen this earlier in another video. And it is composed of a galactose and a glucose monosaccharide each. And these are joined by 1,4 beta glycosidic linkage. And individuals that are lactose intolerant do not make the enzyme that is required for the metabolism or the hydrolysis of that glycosidic linkage. And that enzyme is called lactase. So those individuals who are lactose intolerant do not produce that enzyme and therefore cannot digest lactose. And this causes some unpleasant symptoms. There are medications that they can take that allow them to eat dairy products. Another disaccharide is sucrose or table sugar. This disaccharide is composed of a glucose and a fructose ring. So, and you can see the linkage here. So sucrose is very sweet, as we know, and contains quite a few calories, even though honey is sweeter. It gives or contains less calories than sucrose molecules. Let's see. And in order to reduce calorie amounts, many people use artificial sweeteners. So there are a number of artificial sweeteners that have been developed to use in place of regular sugar. And I think that concludes this. That concludes this short video on disaccharides. And the last one coming up is going to be on polysaccharides.